Hi everyone, this is Doc Wisdom and today we will talk about Earth's internal structure. As everyone knows, the shape of the Earth is spherical, but it's not exactly like this. The shape of the Earth is ellipsoidal because of centrifugal force. The rotation of the Earth makes expand it on the equator. Try to think about pizza, for us Italian food is very important. When the pizza maker makes pastry rotate, it expands. This is exactly what happens to the Earth. But considering size and speed, proportions are completely different. In fact, the expansion of the equator is just 21 kilometers, about 13 miles, bigger than the axe. Could seem a big quantity, but considering the terrestrial ray that is 6,300 kilometers, about 3,900 miles, 21 kilometers is very few. So, as I've just said, the Earth is an ellipsoid, but it's not empty inside. There are different layers. The Earth is like a peach. There is the peel, that is called crust, the pulp, that is called mantle, and the core, that is called core. The first studies about internal division of the Earth were made by a Croatian seismologist named Morovicic, who, analyzing the earthquake of Pokuplje of 1909, noted different delay time. But what is delay time? All waves have different speed. For example, during a storm, you see the lightning and then you hear the thunder. Because in this case we have sound waves slower and electromagnetic waves faster. But waves are influenced also by propagation medium, or more correctly, by the density of the medium. So if the density is the same, what change is just the speed of the waves, like in the case of lightnings and thunder. But if the density of the medium change, we have different speed. And considering that speed is related to time, we have different time. Delay time. Morovicic had arrival time of seismic waves from different seismometers located in different positions, and he noticed that the time expected was different from time recorded. So the question was, why do we have this delay? Morovicic explained this difference with a discontinuity, called Morovicic in his honor later, or easier Mo. This discontinuity separates crust and mantle, so solid and plastic, and also different density. But what kind of crust do we have? There are two kinds of crusts, continental one and oceanic one. Continental crust is where we walk every day. Is above the sea level, or more correctly, ocean level. The thickness of this kind of crust is very variable. It's more where there are mountain ranges. Could arrive at 70 kilometers, about 43 miles. And less where there are oceans. It could arrive at 10 kilometers. Composition of the crust is silicate. Below the crust there is the discontinuity called Mo that marks, as I've just said, the passage between crust and mantle. Mantle is the layer below the crust, is plastic, even if there's a layer inside the mantle called asthenosphere that is liquid. Thickness of this layer is about 2,885 kilometers. About 1,792 miles, and composition is richer in iron and magnesium than crust. Considering the temperature, mantle should be fluid, but because of the pressure that is very high down there, mantle can't be fluid, so it's plastic. Deeper you go inside the Earth, higher is pressure. It's like when you are in the sea. Deeper you go, higher is the pressure, because of hydrostatic pressure. This kind of pressure inside the Earth is called lithostatic pressure. I said that mantle is plastic, so it means that we could have movements. In fact, there are convective movements, the same movements that we have in a pot of boiling water, that are responsible of tectonic plates movements. but this will be the subject of another episode. Below the mantle, or maybe more correctly deeper, there's another discontinuity, so it means another passage. Obviously, when we talk about discontinuity, you should not imagine like a layer, a very marked passage, but more like a zone where properties of material change physically or chemically. The discontinuity that I've just introduced is called Gutenberg, and as Mo marks the passage between crust and mantle, this marks the passage between mantle and core, outer core. As I've just said, when we have a passage, we have also changes in material properties. In fact, outer core is liquid. This is because very high temperature that we have down there. One of the most common questions is, how do we know that outer core is liquid, considering that it's impossible to see it? Now I'll explain you. There are different kinds of seismic waves. Most important are P waves, prime, first, and S, second waves. Considering that S waves can travel in liquid, during big earthquakes there's a zone very far from the earthquake in which we can't find the S waves, so it means that there's a zone inside the earth that is liquid, where S waves can't travel. Thanks to mathematical models, nowadays we can also know the deepness of this layer, that is 2,885 kilometers, and also the thickness, that is 2,270 kilometers. Composition of outer core is silica and aluminium. Deeper than outer core, about 5,515 kilometers, there's another discontinuity called Lehmann that separates outer core from inner core. Inner core is solid and its thickness is 1,200 kilometers. We know that inner core is solid because of two reasons. First, pressure down there is so big that nothing can be fluid, even if temperature is very high. And second, the density of superficial layers. There's a difference between density of the crust and average density of the earth. Because of this difference, we have to speculate that the density of the inner core is very high, so it means that it's solid. Composition of inner core is iron and nickel. We can just speculate this, because 4 billion years ago, when the earth formed, we had a ball of fire, a ball of magma. When it started to cool down, heavier material went deeper, closer to the core, because of gravitational attraction. Those material were iron and less nickel. So our planet has a crust that is solid and silicate, a mantle that is mainly plastic and silicate too, an outer core liquid that is composed by silica and aluminium, and an inner core that is composed by iron and nickel. Obviously, except for the crust, we can't see all layers. You should consider that the deepest hole in the crust, continental one, is about 12 kilometers, so we can know everything indirectly. It's too difficult to go deeper with nowadays technology. Maybe one day we will do a journey to the center of the earth. If you enjoyed this video, thumbs up, share, leave a comment, and subscribe to my channel. Big ciao from Dog Wisdom. See you next week.